Hello everyone, welcome back to another session of an online class. In last class, I was discuss about digital interfacing, and in this class, let us discuss about analog interfacing. So, what is this analog interfacing called? Analog interfacing to an embedded microprocessor address the techniques and methods used in interfacing analog devices to microprocessors, providing in-depth coverage of a particular control applications, op-amp examples, and mesh much more. Okay, so this is about an analog interfacing. Now let us see. In this, you are going to learn about DAC operation and specifications of a DAC. So first, let us see what is this DAC operation called. A digital to analog converter, which means a DAC, converts a digital input signal into an analog output signal. So the digital signal is represented with a binary code, which is a combination of bits, zeros, and ones. This is the block diagram of a DAC operation. You can see a is a digital input going through the digital to analog converter, and then we have an analog output. So here a digital to analog converter DAC consists of a number of binary inputs and a single output. So in general, a number of binary inputs of DAC will be power of 2. And coming to the types of DAC, we have two types. Those are weighted resistors DAC and R2R ladder DAC. Now let us see about the weighted resistors of a DAC first. So a weighted resistor DAC produces an analog output which is almost equal to the digital, that means binary input, by using a binary weighted resistors in inverting added circuit. So a binary weighted resistors DAC is called as a weighted resistor DAC. So as you can see here, I mentioned a diagram of weighted resistors of a DAC. So recall that a bits of binary number can have only one of two values, that is either 0 or 1. Let the 3-bit binary input is B2, B1 and B0. Here the bits B2 and B0 denotes the most significant bit, that is MSB, and the least significant bit LSB respectively. Okay, so the digital switches shown in the above in this figure will be connected to the ground when the corresponding input bits are equal to the 0. Similarly, the digital switches shown in this figure will connected to the negative reference voltage minus VR when the corresponding input bits are equal to 1. So in this circuit, the non-inverting input terminal of an operational amplifier is connected to ground. That means 0 volt is applied at the non-inverting input terminal of an operational amplifier. So according to the virtual short concept, the voltage at the inverting input terminal of an operational amplifier is the same as that of the voltage present at its non-inverting input terminal. So the voltage at the inverting input terminals node will be the 0 volts. So the nodal equation at the inverting input terminals node will be 0 plus VR B2 by 2 naught R plus 0 plus VR B1 by 2 power 1 R plus 0 plus VR B naught by 2 power 2 R plus 0 minus V naught by RF is equal to 0. By further multiplying, we have an equation V naught is equal to VR into RF by R into B2 by 2 naught 2 power 0 plus B1 into 2 power 1 plus B naught into 2 power 2. By substituting R is equal to 2RF in this equation, that means in the above equation, which is V naught is equal to VR into RF by R into B2 by 2 power 0 plus B1 by 2 power 1 plus B naught into 2 power 2. We get the equation V naught is equal to VR into RF by 2RF into B2 by 2 power 0 plus B1 into 2 power 1 plus B naught into 2 power 2. By further calculating, we have V naught is equal to VR by 2 into B2 plus 2 power 0 plus B1 2 power 1 plus B naught 2 power 2. So this equation represents the output voltage equation of a 3-bit binary weighted resistor DAC. So we can write the generalized output voltage equation of an n-bit binary weighted resistor DAC based on the output voltage equation as a 3-bit binary weighted resistor of DAC, which is nothing but V naught is equal to VR by 2 into Bn minus 1 into 2 power 0 plus Bn minus 2 into 2 power 1 plus and so on B naught by 2 power n minus 1. So the disadvantages of the binary weighted resistors of a DAC are the difference between the resistance and the values corresponding to the least significant bit and the most significant bit will increases as the number of bits present in the digital input increases. Okay, and next we have it is difficult to design more accurate resistors as the number of bits present in the digital input increases. So this is about the concept of a weighted resistors of a DAC. Now let us see R2R ladder DAC. So the R2R ladder DAC overcomes the disadvantages of a binary weighted resistors DAC. As the name suggests, R2R DAC produces an analog output which is almost equal to the digital, that means a binary input, by using an R2R ladder network in the inverting adder circuit. So here the circuit diagram of a 3-bit R2R ladder DAC is shown here. So recall that the bits of a binary number can have only one of two values, that is an either 0 or 1. Let the 3-bit binary input is will be B2, B1 and B0. Here the bits B2 and B0 denote the most significant bit and the least significant bit respectively. So the digital switches shown in this figure will be connected to the ground when the corresponding input bits are equal to 0. Similarly, the digital switches shown in this figure will be connected to the negative reference voltage minus VR when the corresponding input bits are equal to 1. So it is difficult to get the generalized output voltage equation of an R2R ladder DAC, but we can find that the analog output voltage values of R2R ladder for the individual binary input combinations easily. So the advantages of R2R ladder DAC are: R2R ladder DAC contains only two values of resistors, that is R and 2R, so it is easy to select and design more accurate resistors. And if more number of bits are present in the digital input, then we have an include required number of R2R series sections additionally. So due to these advantages, R2R ladder DAC is preferable over binary weighted resistor of a DAC. Okay, so this is about the R2R ladder DAC. Now let us see the specifications of a DAC. So the various important specifications of a converter is generally specified by the manufacturers are we have a resolution, linearity, accuracy, settling time, monotonicity, and the stability. So now let us see each one individually. First, let us see what is this resolution called. So the resolution of a converter is the smallest change in the voltage which may be produced at the input or output of the converter. So the resolution should be high as possible. It depends on the number of bits in the digital input applied to the DAC. Higher number of bits and the higher is the resolution. So it can also be defined as the ratio of a change in analog output voltage resulting from change of one least significant bit at the digital input from n bit DAC. So the resolution will be V into Fs by 2 power n minus 1. Coming to the linearity, the relationship between the digital input and the analog output should be the linear. However, particularly it is not so due to the error of the values of resistors used in the resistive networks. Okay, so coming to the accuracy, absolute accuracy is the maximum deviation between the actual converter output and the ideal converter output. So the relative accuracy is the maximum deviation after gain and offset errors have been removed. Coming to the settling time, this settling time represents the time it takes for the output to settle within the specified band, that is I into half 1 by 2 LSB of its a final value after the changes in the digital input. So it should be small as a possible. Okay, coming to the monotonicity, the monotonicity DAC is one whose analog output increases for an increase in a digital input. So a monotonicity characterized is essential in control applications. Otherwise, oscillations can result if a DAC has a monotonic. The error should be less than one least significant bit at each output level. Okay, coming to the stability, the performance of a converter changes with the uh, temperature and power supply variations. So all the relevant parameters such as an offset, gain, linearity error, and monotonicity must be specified over the full temperature and power supply ranges. So this is about the specifications of DAC. So this is about this analog interfacing class. So I will see you in my next class. Thank you.